Hi, this is Raphael Mudge, the creator of Cobalt Strike. Welcome to part 3 of Advanced Threat Tactics, Targeted Attacks. In this lecture, we're going to talk about how to get a foothold in a modern enterprise by executing a targeted spear phishing attack with Cobalt Strike. We're going to talk about client-side attacks and why they matter. We're going to go through how to conduct reconnaissance with the system profiler. We're going to go through Cobalt Strike's attack options. We're going to talk about how to deliver a beacon with a Metasploit framework exploit. And I'm going to take you through Cobalt Strike's spear phishing workflow as well. So what is a client-side attack? A client-side attack is an attack against an application used to view attacker-controlled content. You may be asking, why do we do client-side attacks? Well, it used to be, if you wanted to break into a network, you would scan it from the outside, find something that was a vulnerable service, and try to exploit it. Okay? The world has moved on. It has done a good job at mitigating those kinds of problems, and there's very little low-hanging fruit left in that particular space. So attackers have moved on to client-side attacks. They've moved on to client-side attacks because there's not as much attack surface in front of the firewall as there used to be. Attackers have found it's a lot easier to go around the firewall by sending an attack package to the target, and if they open the attack package, the attacker's malicious package then has an opportunity to attack that target system, and if it succeeds, the target can connect back to you, the attacker, through the target's firewall. This is why we do client-side attacks. Now you may be asking, how do you get a foothold this way? Well, here's my process. Step 1, I like to understand the target's environment as much as possible, okay? Every offensive action really does begin with reconnaissance. And that reconnaissance can be something active, like a system profiler. It can also be open source information gathering, or it could even be a trusted agent helping you save time by feeding you information. Step 2, you're going to want to take the information from your reconnaissance phase and create a virtual machine that mirrors your target environment as closely as possible. This includes patch level, antivirus, and as many applications and version numbers matched as closely as possible. Okay? Step 3, you're going to attack that virtual machine and use it to select the best possible attack situation or best possible attack option for your situation. Okay? Once you've decided which attack you want to use, next, you're going to stand up your infrastructure and you're going to try to clone the attack, you're going to try to dress up the attack to make it match whatever pretext or ruse you have to get the user to believe that your attack is indeed some legitimate order of business. Step 5, you're going to take your carefully crafted attack package, deliver it to your target, and if you paid very close attention to all the details in each of these phases, your likelihood of success goes up dramatically. Now let's talk about client-side reconnaissance. A technology in Cobalt Strike for client-side reconnaissance is the system profiler. This is a web application that the target has to visit. Once the target visits it, the system profiler will do what a good web analytics package does, and it will pull information down about the target. It'll query for different browser plugins. It'll try to discover different applications, all through the information that the browser makes available. It will also try to decloak the visitor's internal IP address. If you want to learn more about what's possible by interrogating a visitor's browser, I encourage you to visit browserspy.dk. Okay, let's take a look at the system profiler. Here we are in Cobalt Strike, connected to a team server in Amazon's Elastic Computing Cloud. Let's go ahead and stand up the System Profiler. Go to Attacks, Web Drive-By, System Profiler. What we're going to do is put in our address, our fully qualified domain name for this team server, which is ads.losenolove.com. And we're going to make it redirect anybody who visits it to linkedin.com. Okay? So just like that. Cool. I highly recommend that you uncheck the Use Java Applet to Get Information box because, well, 2 years ago, that applet was really useful. Java in the browser without a code signing certificate has since become quite useless. Okay, let's go ahead and press launch. And we now have the System Profiler running on ads.losenolove.com. Okay, cool. Now, a couple of things to know. First, View Weblog is where any hits on the web server will show up. Okay? View Applications is where all the information from the System Profiler will show up. Finally, if we go to Cobalt Strike Visualization Target Table, any targets that get added to Cobalt Strike's data model will show up here, okay? So 3 places to look when doing reconnaissance actions like the System Profiler. Let's go ahead and give it a try. Let's surf to the System Profiler in Microsoft's Edge browser in Windows 10. We'll go to ads.losenolove.com/in/, and you can see it's at linkedin.com. Now this is a relatively clean Windows 10 system, but here you can see some of the information we were able to get back. Okay, and there's our hit in the web log. And the event log tells us we gained a profile. And of course, we see a host pop up into our data model as well. Cool. Let's go ahead and try another system. Let's pull up a Windows 7 system. We'll try Internet Explorer. This one's a little bit more dated in its patch level. So let's go to ads.losenolove.com/in. And same thing, you can see I'm at linkedin.com. Very cool. And let's try one more system. Okay, so we'll go ahead and close that. Let's try this one with Google Chrome. And we'll try it with Internet Explorer as well. And you'll notice we're seeing the same external address for these systems. And the reason behind that is we're going out to the internet doing this. So all Cobalt Strike can see is the one point of presence where these systems are coming from. So there's ads.losenolove.com, and we're back at LinkedIn. That's Google Chrome. And let's come over here and try the same thing with Internet Explorer. Okay. And if you're really curious, I'll try the same thing from my Macintosh as well, just so we can get some good variety in our diet, if you will. So let me just pull up Firefox on a Macintosh. And we should have a Macintosh show up as well. Cool. So there we go. We now have a bunch of system profiles to look at. Let me give you a little bit of a tour of this information. Okay. First, you can see the information we were able to gather from each system that hit. You can also set a note on these as well. Like I'll say this is Raphael's Mac. Okay. Now these systems all have, they kind of blend in a little bit because of the same internal address of unknown. But if you look at the date and timestamp, you can tell them apart by this information. Okay. So let's go ahead and go through these real quick. This is the Windows 10 system, and this is the Windows 7 system. with Internet Explorer, Windows 7 system with Google Chrome, and Windows 7 system hit with Internet Explorer. Different browser configurations are going to give us different information. But a few things I want you to know. If you see a *64 next to an application, that means the system profiler has detected that the user is using a 64-bit version of that program. Okay? With Internet Explorer, if you see this JScript line, that 18015 is the build number of the JavaScript engine in Internet Explorer. You can actually map that number back to a patch level for that system, in particular for Internet Explorer. So if you want to know if they're up to date on patches, use this information right here. And in some cases, with some browser configurations, the profiler is able to decloak the internal address. It all depends on the system's patch level and which browser the user happens to be using. Okay, now that we've conducted our reconnaissance, let's talk about our attack options. I prefer to use what are called user-driven attacks. A user-driven attack is not an exploit. A user-driven attack is an attack that takes advantage of built-in functionality in a client-side application. The downside to a user-driven attack is it usually requires fooling the user into taking some action that is favorable to us, the attacker. That said, user-driven attacks have many benefits. First, they're not seen as malicious, so they're very unlikely to get patched. Next, user-driven attacks, because they are built-in functionality, work across a wide variety of versions of whatever application you're targeting. Next, user-driven attacks are pretty awesome because they're very reliable. Once the user takes the action needed to trigger the attack, it's just as good as if the user had run an executable or taken some action to put your malware on the box. You don't have to worry about all the pain that goes with memory corruption, okay? So I am a big fan of user-drivens. Cobalt Strike gives you several user-driven attack options. There's the HTML application. This is an HTA file that can use a PowerShell one-liner to get a payload into memory, or drop an executable to disk and run it. There's the Java signed applet attack. This is a Java applet. It gets embedded into a website, signed with a code signing certificate. Okay? The Java signed applet attack prompts the user and asks them if they want to allow the attack to run. If they do, they've just given you free code execution on their system. There's also the Microsoft Office document macro. This is a macro that embeds into an Excel spreadsheet or Word document, and if the user allows it to run, they've just given your payload a free pass into memory. There's also the PowerShell web delivery attack, which is a PowerShell one-liner that if you can get the user to run it or embed it into something else that runs it for you, this will download your payload and inject it into memory. Finally, there's the Windows dropper. This is an executable that drops a document to disk, opens it, and executes your payload in the background. Okay? The Windows dropper is pretty effective if you take the steps to disguise it by changing its icon to look like a document. It's particularly effective with out-of-band delivery techniques that don't involve email. Things like mailing a CD to your target. The HTML application is the new user-driven, I shouldn't say new, it's been around forever, but it's the user-driven that many pen testers are gravitating towards today. HTML applications aren't very common out in the wild, so I think personally that this attack does not have a lot of life left. I could be wrong, but whatever. Let's talk about the Java signed applet attack. The default version of this attack in Cobalt Strike uses a self-signed code signing certificate, okay? That self-signed certificate will not work in any Java update since January 2014. If you're going to take advantage of this attack, you have to purchase a code signing certificate and use it to sign Cobalt Strike's applet attack. We'll talk more about that in part 9 of this course. The Microsoft Office document macro is today one of my favorite attacks still, okay? So that's a good attack to use. Okay, let's take a look at a user-driven attack in Cobalt Strike, okay? First things first, I'm going to go back to the table view for my sessions so I can see any new beacons that come in, okay? Now, Cobalt Strike's user-driven attack options are available under Packages and Web Drive-By. Later on, in part 9 of this course, I will show you the signed applet attack, and I will show you the Microsoft Office macro. For now, let's go ahead and take a look at the HTML application. So tax packages HTML application, and we get the option to generate an HTML application that runs our payload with an executable or PowerShell. We'll use PowerShell, and let's go ahead and create a listener real quick. We're going to call this EC2 beacon HTTP. We'll put in our address, which is ads.losenolove.com, port 80. Press save, and we'll have it beacon back to ads.losenolove.com. Cool. Let's go ahead and press generate, and it's going to ask us where to save this file, and we'll call it updates.hta. Why not? And there we go. Now, we need to get this HTML application to a target. Let's go ahead and host it on Cobalt Strike's web server. Let's go over here to this link, and we'll navigate to updates.hta, and we'll host it as updates.hta. Very cool. Let's put in ads.losenolove.com as our local host, hit launch, and there we go. We now have a URL that a target can surf to pull down this HTML application attack. Let's come over here to a target system, pull open a browser, and let's surf over to this HTML application and press run. And it's going to ask if we want to run it. Sure. But there you go. You can see in Cobalt Strike that we have a foothold in this network on this Windows 10 system. So that's an example of the HTML application attack. On top of the different user-drivens, Cobalt Strike also generates executables and DLLs that get your payload into memory. Use attacks packages Windows exe to generate an executable or DLL with a payload stager inside of it. Use attacks packages Windows executable S to generate an executable or DLL for a stageless beacon. A stageless beacon is a beacon without a stager. It is the entire beacon inside of that DLL or executable file. When you export a DLL, if you want to start it with rundle32.exe, you can. Just do rundle32.exe, whatever DLL, comma, start W. You may also use Cobalt Strike's web server to host your files. Just go to attacks, web drive-by, host file. And you can upload a file to the team server, and Cobalt Strike will host it on its web server. If you want to manage and remove hosted files, go to attacks, web drive-by, manage. If you want to see visits to your web server, go to view, weblog. All visits to your web server will show up in this tab. Now, Cobalt Strike does have some protection against curious blue teams in its web server. If Cobalt Strike observes a request with a user agent of curl, wget, or links, Cobalt Strike's web server will automatically return a 404 response.